Dear students, in this lecture, so we are going to start a new concept, and it is an interesting and most important concept, that is a differentiation. So the differentiation is a technique which can be used for analyzing the way in which the functions change. So in particularly that derivative or differentiation measures how rapidly a function is changing at a particular point or at any point. So we shall discuss in this chapter like a differentiation. So the derivative, so which forms a basis for the fundamental concepts like as we know, the velocity, acceleration, right? So like v of t, velocity, acceleration, and jerk. So whereas in our mathematics, the slope of a tangent to the given curve at a particular point. Now, so before starting the concept of the differentiation, so you should understand the functional notations. So as we seen in the notation for a function in the functions chapter, right? So that is represented by y equals to f of x. Y equals to f of x. Now, as the change in y is depends on x. So that so the x is always an independent only. So here the variable x is known as independent. So this is independent variable, and so this y is dependent on x. So that it is called a dependent variable. This is dependent variable. As we seen here, x is the input value and y is output value. So for the function. So depend on x or the input, then y is changing. So let us suppose that a function, a function f from I to r, I is an interval, so that may be an open interval or closed interval, so which is denoted by the function denoted by y equals to f of x. So as we know, x is independent and y is dependent. So let us take a point in the given interval I, let it be, it is c. So let the point c is any point in the given interval. So for any number, any smallest number h, which is a positive quantity, and the number c plus h is also belongs to that interval I. You want to know c is belongs to I, so h is any positive or the smallest positive quantity, then c plus h also belongs to I. So c plus h kuda I lo unde vidhanga h nu consider cheskunnam. And so this quantity c plus h is lying either left of c or right of c. So if let it be, this is on our interval, so there exists number c. Now so h is any positive quantity, then c plus h is again a number, then this is the neighborhood of c. So this number c plus h may be either left of c or right of c. Anyhow, it is in the neighborhood of c. Then so here here I is c is belongs to I, right? So if we give c as input for this function y equal to f of x, then f of c is a function value. So and if we give c plus h, then so we get y as f of c plus h. Then f of c plus h minus f of c. So which denotes the change in, this denotes the change in f of x, right? Difference. So the difference, this indicates the change in f of x. So which corresponding to c plus h minus c, that means h in x. So this is the change in f of x, and so this is change in x. C plus h minus, so these are the x values and these are y values. F of c, this difference is nothing but change in f of x. So this difference is nothing but change in x. Therefore therefore the ratio that is f of c plus h minus f of c divided by c plus h minus c, or so this h is called average change in f of x, or so we may call this as average rate of change in f of x, average rate of change in f of x. As we seen this ratio in the analytical geometry, right, to find the slope of a curve, slope of a line at a particular point for the given curve. So like it is y2 minus y1 by x2 minus x1, right, x2 minus x1. So means this is a change in y divided by change in x. Change in y divided by change in x is nothing but average rate of change or average change. So let us see graphically or so geometrical interpretation for this rate of change or average rate of change. So for that, so let us consider the given function y equals to f of x. So consider the function y equal to f of x. So x is input and y is output. Here x is domain and y is range. Now, so let it be the given curve y equal to f of x is so like this. So this is the curve of y equal to f of x. Now, so there is a line that passing through these 2 points. Let it be it is A and B. Now, so this is let it be this is the point x. So the corresponding to x is there is some y, or it is a f of x, like it is f of x only. Now, so let it be this is some x plus h, let it be this x plus h, so that the corresponding y value for this is f of x plus h, f of x plus h. So x is any point on the line or x axis, and so h is any small number, then x plus h is also lie on this. Now, so here the chord AB or the line segment AB, that represent a line in the plane, or AB is a line segment, or AB is a chord of the curve. Now, so the point A is x comma f of x, right? This is x comma f of x. And so what about the point B? So the coordinates of B are x plus h comma f of x plus h, right? Right. So by using this, so there is a change in x, there is a change in x, and so this indicates change in y. So the difference, this difference is nothing but change in y coordinate, and so this difference that indicates change in x. So here the difference that is f of x plus h minus f of x, and here the difference is x plus h minus x is nothing but this is h. So here the rate of change is f of x plus h minus f of x divided by h. So this indicates the slope of this curve, right? The slope of this line segment or line. Now here h is a small value. Here I am saying the h is any positive value and which is very small. Now, so the small value that h maybe leads to 0 also. As h goes to 0, then what happens? As h goes to 0, then say the graph will be looks like this. H value 0 and then line out. So the line that so coincide with the point A. So therefore the line will be like this. Now, so this is the line that is known as tangent line. Now here it is AB, or this line AB is known as secant line, and this line is known as tangent line. So here when h is goes to 0, therefore this line AB that becomes like this. right now. So mathematically, as h is goes to 0, as h goes to 0, the chord AB becomes a tangent at the point A, right? And the limit h tends to 0, f of x plus h minus f of x divided by h is called the derivative or the rate of change for the given function y equals to f of x. So means, so the tangent is nothing but, or the derivative is nothing but the tangent for the curve y equal to f of x at a point, at a particular point. Here x is any point on the line or x axis. As h is goes to 0, then this chord AB becomes the tangent at A. So this is called the rate of change or the derivative of f. So let us see the definition of derivative. So using this concept, see the derivative of the function y equal to f of x or f. So with respect to the variable x is the function, and f dash is the function f dash whose values at x is the limit, that is this limit is denoted by f dash of x. So with respect to x is f dash of x is equals to limit h tends to 0, f of x plus h minus f of x divided by h, where h is non-zero. So maybe it is nearby 0 but not 0. So provided the concept of limit is exist, provided the limits will be exist. As h is goes to 0, the limits are exist means as h goes to 0 minus and h goes to 0 plus, then this may leads to some finite value. So x is any point. So if this f dash is exist, so we say that f has a derivative. The function f has a derivative at x, or f is differentiable at x and all. Okay, if it is exist, if the limit is exist, then we say that the given function that has a derivative. And so this is known as the first principle of derivative also. So the definition of the derivative is known as the first principle of, this is known as the first principle. First principle of derivative. Or the fundamental definition of derivative also. So let us see the notations for the derivative of y equal to f of x. So the notation, so for the function y equals to f of x, y equals to f of x. So if f is differentiable at any point x, then the notation for this is denoted as dy by dx or df by dx or f dash of x, or so we may call this as a prime. This is nothing but prime, or so y prime. So we need we read it as y prime. The power, this indicates a prime. So and so this can be read it as dy by dx. dy by dx అని చదువుతాం. దీన్ని y dash or y prime or f prime of x also. dy divided by dx or d by dx of y. dy by dx or d by dx of y. So where dy by dx or d by dx of y means the rate of change in this variable with respect to this variable. Okay, the rate of change in y with respect to x. So whereas in the velocity, the change in position, right, with respect to time and time. So ds by dt on the ds by dt. So that indicates the rate of change in this s with respect to t. Right, so this indicates the velocity, right? And similarly rate of change in velocity ఉంటుంది కదా, so that is dv by dt. dv by dt means it is acceleration. acceleration. The change in position is nothing but velocity. Change in velocity is nothing but acceleration, and change in acceleration, so that is dA by dt. The change in acceleration is known as jerk. Change in position is velocity, change in velocity is acceleration, and change in acceleration is jerk. Okay, let us write some note points. So the number 1, see here what we call the definition of the derivative, that is the first principle of derivative, right? So write down the point. The definition of derivative is also called first principle. First principle of derivative or differentiation. First principle of derivative is nothing but limit h tends to 0, f of x plus h minus f of x by h. Or so you can write one more time. So this is nothing but f dash of x is equals to limit h tends to 0, f of x plus h minus f of x by h. So this is called the first principle of the derivative, as h is not equal to 0. Here, so you know the concept of limit. It exists outunante compulsory limit another exist kavali. Here f dash of x is defined means, so as h is goes to 0, then this may leads to some finite value. Now, so here we may have a doubt. Here what is x? X is always variable? No, so here x is any number, so the derivative will be exist. So for example, let us take x equals to a. X equals to a means, so this is differentiable at a. Differentiable at a. So f dash of a, that can be written as limit h tends to 0. Now, so this is f of a plus h. F of a plus h minus f of a divided by h. So this is nothing but the derivative of f at x equals to a, or dy by dx at x equals to a. So if we simplify this formula, then so we may get the result in terms of x. Here it may be a constant. And so the alternative definition for the derivative is again using a limit, that is f of f dash of a, which is equals to limit x tends to a, f of x minus f of a divided by x minus a. So sometimes also you may use like this. So both are same, right? As x is goes to a, therefore then so that leads to x plus h, right? Or a plus h. If x equals to a plus h replacement kondi, then again it is same as this one. Here x is a plus h anukunnatlaithe, x is a plus h. See, already x goes to a antunnanu, ante then meaning enti? H tends to 0 ne kada. X is a anappudu x plus, so there are a plus h, that becomes h tends to 0. So you need to remember so these two formulae to evaluate the derivative of given function. So the function is anything, then so we may evaluate the derivative for that respective function over the domain of the respective function only. Okay, we may use. So both the things are, so this is an alternative definition for the derivative at x equals to a. So next, so how to calculate the derivatives for the given functions, or calculating the derivatives from the given definition. So to find the derivative of a given function, so we must introduce the definition only. So see here, the process of calculating the derivative of a given function is known as the differentiation. The process of finding the derivative is nothing but differentiation. See the procedure. So here the procedure also defined derived from the definition only. So let us see. The first one is so here you need to write the expressions. Write the expressions for f of x and f of x plus h, right? F of x and f of x plus h. So in the problem, the function may be in terms of y equal to something. So y is nothing but f of x only. So that first you need to write the expressions for f of x and f of x plus h. And second, expand and simplify the difference quotient. You know the difference quotient, right? So that is f of x plus h minus f of x by h. So after these two expressions, so try to evaluate or try to simplify f of x plus h minus f of x by h. Next, third one. So using the simplified quotient, then find f dash x. So by evaluating the limit, right? By evaluating the limit, that is dy by dx, or we may call this as a f dash of x, right? F dash of x, which is equals to limit h tends to 0 f of x plus h minus f of x by h. So for this simplification, just apply the limit as h is goes to 0. Then so we may get f dash of x or f prime of x, where h is not equal to 0. H is any positive quantity but not equal to 0. So these are the three steps to evaluate the derivative of the given function using the differentiation, or we may say this is the first principle. Then fundamental principle or the first principle of derivative. First principle. So let us see some examples how to find the derivative of the given function using the first principle of derivative or the fundamental definition of the derivative. So example 1, find the derivative of y equals to mx plus c, where x and y are variables and m comma c are some constants at any point x. Now we have the procedure to find the derivative of a given function by using definition, right? So here y equal to mx plus c is given. Now here we have y equal to f of x, right? Y equals to f of x, where the f of x can be written as, where this f of x is mx plus c, right? And so by using this, so we can express x plus h. F of x plus h can be written as, so just replace x with x plus h. So we may get like this, m of x plus h plus c. That means m into x plus m into h plus c. So now we have f of x and f of x plus h. Now so second step in it. So we need to expand and simplify the difference coefficient, right? So that is f of x plus h minus f of x by h find again. Now so we have f of x plus h. F of x plus h is what? mx plus mh plus c. And f of x is, this is minus, f of x is mx plus c divided by h. Now so this is mx plus mh plus c. Now it is minus mx minus c divided by h. So here c and c gets cancelled, mx and mx. So the remaining is mh by h only. So here h and h gets cancelled, then so finally we have m only. So here so the simplified difference coefficient will be m only. Next finally we need to find the limit for this. So that is f dash of x, or you can write the first principle of this. F dash of x is nothing but limit h tends to 0 f of x plus h minus f of x by h, right? Now so this is equals to limit h tends to 0. Now so already we have this difference coefficient. Simplified difference coefficient is m. So this is m. M is a constant. As h is goes to 0, a constant is always a constant. Therefore the derivative of the given function, that is f dash of x, is equals to m. So the derivative of this is m, or dy by dx also no problem. So what is the derivative of this y equal to mx plus c is nothing but m only. This is also m, or you can write like this also, no problem. F dash of x is m, or d by dx of y is also m. So next example. So show that the derivative of a constant on real number set is 0. So the derivative of any constant is 0 and prove. So means f dash of any constant is always 0, or d by dx of any constant is equals to 0. So we need to show. Now if we show this the derivative of constant, so directly we can use like derivative of the constant, or 100 or 200, anything will be 0. We can write directly. So they see the solution. So here what is given? You need to consider a constant function. So let f is a constant function. F is a constant. Or f be a constant function. That means f of x equal to c another. F of x equals to c. Here x is any real number. So this is c for every real number r. Now f of x is c. Then if x is any number, like x is any real number, so x is 1 also c, 2 also 3 also c. So x is any number, then f of x defines only constant. So if it is f of x plus h is any small positive quantity, then f of x plus h also c, right? Now so we need to find the derivative, that is dy by dx. So that rushes run. So that means f dash of x, right? F dash of x, which is equals to, the definition is limit h tends to 0. Now it is f of x plus h minus f of x by h. So this is the formula, or the fundamental principle of the derivative is this one. Now so apply this formula for the given function. That means f dash of x is equals to limit h tends to 0. Now f of x plus h is c, minus f of x is also c, divided by h. Now so this is a limit h tends to 0. Now c minus c, so 0 pin. So this is a 0 by h is 0. Now as h is goes to 0, then 0 is 0. So the f dash of x value is 0 when the given function is a constant function. F of x is any constant, then the derivative of that constant is always 0. Or so here you can generalize a point, that is the derivative of a constant is always 0. The derivative of constant. So for example, we can write like this. Here if it is a d by dx of 5 undanukondi, so directly you can write it as 0. Next d by dx of 100 undanukondi, the derivative, so 100 is nothing but a constant, so the derivative of a constant with respect to any variable is always 0. Or d by dx of your ID number, so b20 so and so, so it is a constant, therefore it is 0. And d by dx of let it be this pi, you know the pi is an irrational number, so this is also 0. Or the derivative d by dx of e is an irrational number or exponential number, so this is also 0. So here we can conclude that the derivative of any constant is 0. If we take f of x is any constant, then the constant minus constant also, so that's why it is 0. 0 enduku avutundi ante reason idi. This is the reason the derivative of a constant function is 0. See the third example. Suppose f of x is given, this is a square root of x, root function. Prove that f is differentiable on 0 to infinity. Since the domain of this is 0 to infinity, means x is always greater than or equal to 0, then so given that root x and x is greater than 0, so we need to show this function is differentiable on 0 to infinity, then also find f dash of x. The differentiable అయితే f dash x ఏంటో కూడా find out చేయాలి. Okay, now so here what is given, f of x value is given, right? So f of x equals to root x. So given that f of x equals to root x, so by using this, so we can write f of x plus h also. f of x plus h, what it is, root of x plus h అవుతుంది, where h is not equal to 0 and h is mod h is less than x only. The value of h is mod x కంటే తక్కువ ఉండాలి కదా, సో mod h కంటే తక్కువ ఉండాలి, so it is lies between h is lies between minus x to plus x. Then see the first principle of derivative is what is our definition? Write down the definition. F dash of x is equals to limit h tends to 0 f of x plus h minus f of x by h. So this is our first principle of the derivative. This is the first principle of the derivative. Now so directly you can simplify here only, here itself. Now so which is equals to limit h tends to 0 f of x plus h is root of x plus h minus root x divided by h. Now so this is the thing. Now if you apply the limit directly, as h is goes to 0, then it is root x minus root x by h is 0, so 0 by 0 indeterminate form. So if the function is if the limit is in indeterminate form, you know how to evaluate, right? So the numerator that contains radicals, so that we need to rationalize the numerator. So we need to rationalize the numerator like root of x plus h plus root x by same root of x plus h plus root x. Now so this is limit h tends to 0. Now so it is a minus b into a plus b form, so that it is a square minus b square means root of x plus h whole square minus root x square, that defines or that indicates x plus h minus x divided by h into root of x plus h plus root x. Here x and x will be gets cancelled, x and x, so the remaining part is limit h tends to 0, then this is a h divided by root of x plus h plus root x, sorry, into h is there, so h and h also gets cancelled. Then finally so you can apply the limit here, you can apply the limit. So limit h tends to 0, numerator constant is there, then that is 1 by 1 divided by h tends to 0, this is root of x plus h means root x plus 0 plus root x. Root of x plus 0 is root x only, so 1 by root x plus root x, that is 1 by 2 into root x. So therefore the derivative of f of x is 1 by 2 root x. So you can remember the derivative of root x when x is greater than 0, that is 1 by 2 root x. Or so you can write it as a dy by dx of, or dy dx of root x is nothing but 1 by 2 root x. So next the fourth example. So show that the derivative of sin x is cos x on the real number set. So here we have to show the d by dx of sin x is cos x. So here what is given? Sin x is given, so let us take f of x equal to sin x, right? So let x is any real number, x is belongs to R, and then for h is not equals to 0, so we have sin x, f of x is sin x, and f of x plus h is also, right? Or before that f of x plus n, f of x equals to sin x, and f of x plus h is what? So this is sin of x plus h, right? Sin of x plus h. Now so write down the first principle of derivative, that is f dash of x is equals to, so to remember the formula, so again I am writing this is f of x plus h minus f of x, 3-4 times రాయండి గుర్తుంటుంది. So this is the first principle of the derivative, right? So by using this principle so you can evaluate the derivative of any function. Now so simplify this, limit h tends to 0, then f of x plus h, f of x plus h is what? Sin of x plus h, so this is a sin of x plus h minus sin x divided by h. Now as h goes to 0, then it is sin x minus sin x by 0, so 0 by 0 case, so that we need to use the transformations here. So this is sin c minus sin d, right? Sin c minus sin d, you know the formula for sin c minus sin d, that is 2 into, now it is cos of x plus h plus x by 2, into sine of x plus h minus x by 2, right? Now so divided by h, sin c, or you can write the formula sin c minus sin is 2 cos of c plus d by 2 into sine of c minus d by 2. Now so this is a limit h tends to 0. Now say 2 into, and what about this cos of x plus x, 2x, so that we can write it as cos of 2x and x plus h by 2, x plus x, 2x by 2 means x, h by 2 into sine of h by 2 is there, x and x gets cancelled, then so the remaining part is h only, h by 2 divided by 2 is there, sorry h, okay, right. Now so here we can simplify this as limit h tends to 0. Now so this is a cos of x plus h by 2, right? Cos of x plus h by 2 into sine of h by 2 is there, divided by h, and so this 2 can be written as h by 2. Now as h is goes to 0, then say it is in the form of f into g form, f of x into g of x, so that you need to apply the limit for both the functions, right? So as h is goes to 0, now cos of x plus h by 2 means it is cos of x plus 0 then, into, now you need to apply the limit this, so let h by 2 is y అనుకున్నట్లయితే ఏమవుతుంది, y tends to 0 అవుతుంది, so sin of limit y tends to 0 sin y by y, sin y by y is 1, this is 1, like it is sin theta by theta formula ఉంది కదా, sin theta by theta is always 1, so therefore this is equals to cos x. So f dash of x equals to here, f dash of x equals to cos x, which is here x is sin, the derivative of sin is cos x, or we can write this as d by dx of sin x. So you need to remember, so d by dx of sin x is cos x, the derivative of sin x is cos x. Or similarly you can evaluate the derivative of cos x, derivative of cos x is minus sin x వస్తుంది, so prove చేయండి. So by using this formula you can evaluate the derivatives for all trigonometric ratios also. So dear students, I hope you understand how to evaluate the derivative of a function.